All right, today we're gonna make a quick video on my favorite large language model, and this is gonna be Meta's Llama 3.3, and this is the 7 billion parameter model, compressed down to instruct, essentially using NVIDIA's FP4 quantization. This is highly optimized for the Grace Blackware architecture, of which this model is sitting on. It's actually sitting on a cluster of GB10s. So to the right is a DGX Spark with 128 gigabytes of RAM. To the left is Acer GN100, which is essentially the same thing as the Spark. It's just a different case and different cooling. And they're connected together with a CX7 connector, high speed. All right, so we have the model loaded into memory. This is it's compressed down, but it is actually I forgot the term. It's not a model of experts, but essentially, anyways, it's the big model, and over here it's about let's say 100 out of 128. This is the lead node, and then over here is the worker node. For those who don't know, quick kind of overview. When you cluster a system together, in this case, we're using NVIDIA's NCCL as the memory management tool, and it's also being orchestrated by this program called Ray, or a system called Ray. And essentially, what you do is you connect the two devices together. Ray recognizes there are two GPUs. They're connected together using the CX7 connector, and it sends that information over to NCCL, which is NVIDIA's memory management system. And when you load up the model, NCCL or Nickel will then place the model as it sees fit. And I think in this case, models have what's how it's called layers. And essentially, I think there are 32 typical layers, and half the layers are done on the first 16 layers are done on the lead node or the host or the main node, and then the worker node has the remaining 16. So anyways, let's go ahead and do our typical quote. Tell me all about, I misspelled that on purpose, Tyrannosaurus Rex. Okay. There's a lot of typos in there. That's done on purpose, but tell me all about Tyrannosaurus Rex. And let's go ahead and see what it goes. Very quickly, you see during inference that the prefill has started very, very fast. You're starting to see the bottom, the host node here, the GPU utilization has gone ahead and it's getting sporadic, but it's actually using it. It's going up and down because it's trying to figure out what it's trying to do. It's actually spitting out the words right there. It's an unreasonable speed. That's looking like, I don't know, 8 words per minute, or sort of tokens per second, and that's not usable to me. But if you look at here in terms of CPU utilization, it's at 91%. So that worker node is really, really being put to work. If you take a look at the cores right in there, it's all over the place, right? 50% over there, 100% over here, 99% over there. Yeah, it's all over the place, but definitely consistently being used. Over here, it's back and forth, right? 120. Whereas over there, it's consistently 90 something. And the reason why that is because essentially it's determining what the work is. That thing is spitting out the words on decode, and that is actually doing all the pushing of all the data, right? So this is pretty much transferring the text one by one. That's why it's going up and down. If you look at the memory, the GPU utilization is up and down. Memory's pretty consistent across the board. The compute cores are active all over the place. It's still spitting out the code or the text of data, but that's not a very good token speed. So I'm going to make another video using the NVIDIA Nemotron 120B, and you'll notice that even though it has more, I guess, parameters, because it is quantized and it's a model of experts, it's only using like, I think 12 billion parameters as opposed to 120 billion parameters. So it's able to show the tokens a lot faster because of the model of experts. And so because this is not model of experts, it's having to go through the entire data set, which is why it's taking so slow to spit all that stuff out. And so here just wanted to demonstrate, just because a model is big doesn't necessarily mean that it's slow. Just because a model is smaller, it doesn't necessarily mean that it's faster. So here we go. That is Llama 3.3770 billion parameter instruct compressed in NVIDIA 4-bit. No, it's okay. It's not hot or anything. These things have fans and you can't really hear anything. All right. Thanks for watching.